Alright guys, so the heading says application of sine, cosine, and arrow, just because it's now a question where you're gonna have to use those tools. Like even though it's like it's always referring to stuff that you've done before, and it's actually how you use sine or use cosine or what you need to do. You kind of look at the picture and figure out what you have to do, right? Now in this question, we're actually working, or we have three triangles. We have a big right angle triangle. Yeah? No problem. Then we have the smaller right angle triangle, which is on this side. I want you just to make a note that on the side of this triangle, this one is right angled, meaning that we could use pi back possibly, or we could use sine, cos, or tan. If we haven't done it in a while. Might be a bit rough on that. But it is a right angle triangle, that one. So we are actually allowed to use the normal right angle triangle thing. Okay, if we have to. Then there is a third triangle, which I haven't spoken about yet, which is this one here on the side, which is not right angle. Okay, so in this triangle, we would only be allowed to use sine or cos. So this is not right angle. Right angle. So we can only use sine or cos in this outer triangle. Right, we need to find x, right, which is AP here at the bottom. So this is the side that we are meant to find. Now, what I want you to write down, here we go, let's write it like next to the heading. So these questions where you have multiple triangles, right? You have multiple triangles. I think that's clear to everyone. The first step, usually, I want to say 99 out of 100 times, is going to be to find the shared side, the common side between the two triangles. So if we're looking at these two triangles, I know we do have a third one as well, but just the two triangles that are next to each other, we agree that PC or CP is a side that is common to both sides, right? So that is what we are going to find first. So I'm actually going to highlight that side. Right, and I'm going to make it quite dark because it is very important. And guys, if you don't know what to do in a question like this, again, 99 out of 100 times, if you just find the common side and the shared side, you will get a mark for that already, even if you don't know what to do or what to write. Okay, so just next to my heading, I'm going to write here, find the common side. That is usually our starting point. Right, so in this triangle, the common side is CP, so I'm just going to write here, the common side is CP or PC, doesn't matter, you can decide. So our first point that we're gonna, or first thing that we're gonna try and find is how do we actually calculate the common side? So guys, if you're looking at this triangle on the outer side, right, the one that's not right angle. So I have enough information to calculate PC. If I want to I usually check for sine rule first, okay? Remember, it's not a right angle triangle, so you can only use sine rule. So if I wanted to use sine rule, I need the opposite angle, which I do have. But do I have another pair of opposite side and angle? No. All right, so now we look at the right angle triangle. If I want to find PC, guys, do I have the other two sides? So that I can use my side. Remember, if I want to find one side using pi that, I need the other two. Do I have the other two? No, I just have one. Okay, so we can't use pi that. Then we maybe use sine. What is sine again? Sine is opposite over hypotenuse. So we have 75 degrees here. Do we have the opposite side? Yes. And what side is here? Is the hypotenuse. So in this triangle, guys, because it's a right angle triangle, we can actually use sine to find CP. All right, so I'm going to write here sine of 75 degrees, only 15. Sine of 75 degrees is opposite over hypotenuse. So 15 over CP. Just add a little note next to that. I'm just going to say, remember, this is the opposite side. This is the hypotenuse. That's where that's coming from. We're not using sine rule, guys. It's a right angle triangle, so we're using sine, right? Opposite over hypotenuse. Remember, I want to find CP because that's the common side. And that's the reason why we're finding it, because it is a common side. So if I have this, I can use it in the other triangle as well. So actually what we're trying to do is we're trying to find more information in the second triangle. Right, because I want to find x, which is in the second. Alright, so now to get CP on its own, I need to multiply it out. So I'll have, I'll have CP sine 75 or times sine 75, if you want to write the time symbol there, is equal to 15. And then what does that do with that sine 75? Divide by, okay? So I'm going to say CP is equal to 15 over sine 75. Right, you can type that into the calculator. And the answer that I got was, the answer in the book, 15,53. So guys, I'm writing a rounded off answer rather, but remember you must keep the answer in your calculator. Okay, so I'm just going to write here. Calculator. Because it's not the final answer, so we're not actually allowed to answer. Okay, so now if it helps, probably will help, let's put that on our picture. 15,53. Okay, now we need to start thinking, how can I calculate x? Right, remember that is what we're trying to find. So guys, you see, by finding the common side, I have an extra piece of information now in that time. Okay, because we only had one angle. That's the only thing that we had in the triangle. At least now we understand that. Okay, what do we think? Let's see, can we find sine rule? Remember, I'm trying to find x, right? So when I use sine rule, I'm going to have to say x over sine of the opposite angle. Do I have that angle? Do I find it? How can I find it, guys? We could do angles on a straight line here, hey? And then angles on a triangle. Alright, we could do that. Or I know we don't usually like working with exterior angle, but you could use exterior angle of a triangle. This 75-degree angle is the exterior angle of this triangle, right? And what must the exterior angle be equal to? The sum of the opposite interior angles, which is 55 and that angle. So if 55 and that angle is out of 75, what would that angle be? Okay. All right, so that's going to be the next thing. Or you could do angle straight line and angle sine triangle. Perfect. You'll get the same answer. All right, so I'm just going to write here ACP is equal to 75 degrees, which is that exterior angle, minus 55 degrees, which is the one interior angle that we have. And my reason for that is exterior angle of triangle. The ACP is 20. You can also just write ACP equals 20 straight away. You don't have to actually show this. You must have that reason. I'm just going to have to move it down again. All right, so now we have that angle is 20. Let's see, can we now use sine rule to get x? X over sine of 20, and then do we have another pair of an opposite side and angle? Yes, all right, it's 15,53 over sine of 55. All right, here we go. So now I'm going to say, therefore, x over sine of the opposite angle, so sine of 20, is equal to 15,53, that is the side that we calculated, the common side, over sine of the opposite angle, which is 55. Right, to get x on its own, we need to take this fraction and multiply it by sine 20. And remember, guys, this 15,53 is still from the calculator. So we could use the answer button for that. Now the problem is that if you use the calculator to calculate this 20 degrees, right? Then this is not going to be your last answer. So just be aware of that. You might actually have to work that out again if you use your calculator to do it. Okay, but it's not a lot that you have to type in to do that. It's just 15 over sine 75. That answer is in the book it says 6,48. Right. 6,48 centimeters. Alright, so guys, the key to this question was calculating that common side. Right? If you didn't find the side, then you wouldn't have been able to work it out. You probably wouldn't have realized that you needed angle C, right? And then you wouldn't have been able to work it out. So really finding the common side is very important. Alright, we're going to do a circle one now, because unfortunately this bracket circle geometry. So sorry, you guys are going to have to draw a circle now if you have a compass or you know, even like a foot or something. Alright, that is the thing. Like that. That will be amazing. No, but you guys normally don't come into the last block. I start logging into the order the longest. Maybe like no. I don't like the result. I don't know. Your exam starting on the 7th, right? And then it's 3 weeks. Mm. The 4th week. I think it starts on Monday the 7th, yeah. And then it should be 3 weeks, and then there's only like a week after that of like and that's not like okay. I don't know, it's just a bit bad in the fall. But like in the school days, maybe not after this. Yeah, that's okay. This is one of the how I'll go this first. I can go this first so I can try and be better. I don't know how All right, guys, so we notice that OB is a radius. We have another radius on the OD. So if OB is 8, then OD is going to be 8. So now I'm just adding that in blue because I'm going to use that. I'm going to have to say OD is 8 with my reason is actually a radius. Okay? What else can we find in this picture? It's maybe it's actually a good idea to look at what we're trying to find. Okay, we're trying to find 8. In this question, it's not really like the question that we had above where you have to find like a common side because there's so many different triangles here that even figuring out which side is now common is a bit complicated. Okay, so for these questions where you're not sure what is the common side really, I mean in the first example, it was easy to see, right? The common side there is just one possibility. Okay, so that one you will have to find. In this one, because there's so many triangles and so many lines, let's actually look at what we're trying to find. We need to find x. Right? Now, if I want to find x, firstly, is this triangle, because x is the side of the triangle, is this a right angle triangle or a non-right angle triangle? Non-right angle. So I'm going to have to either use sine rule or cos rule, okay? I'm also just going to write that thing. And that does help, guys, if you just actually recognize that, because then you can start thinking, okay, if I want to use sine rule, what do I need? If I want to use cosine rule, what do I need? Okay, it's quite useful to just do that at the beginning. So now guys, it actually looks to me like I could use cos rule here, right? If I just find that angle. Remember, what do I need for cos rule if I want to find the sine? I need the other two sides, which I do have here, and then I need the included angle. So the angle that's opposite the side that I'm trying to find. Now, is there a way to find angle BOD? And I think that we have BAD, right? So BOD, this one, and that one, those two are it. Yes, I have angle C, right? Now, if I want to do angle C for angle C, guys, then angle C is half of that angle there. You guys remember that? So that's like on the way around. So we could do that, and then we could do revolution to find that out. Okay, good. So we can say that reflex, now you have to be very careful, guys. If you just say BOD, the marker is automatically going to speak about that one. So you have to say reflex BOD for this one. Okay, what is the angle at the center? Always double the one at the circumference. Okay, so we're going to say reflex BOD is equal to, what is 180 times 2? 236. And then that long reason, hey, I'm just writing it underneath. I'm going to cross 2, 4. Angle center equals 2 times angle at circumference Okay, so this one is now 226. But we need that inner angle BOD, so we're going to have to do revolution. Okay, so we're going to have to now say BOD, we have reflex BOD, but now we're finding BOD is 360 minus 236. The reason for that is revolution. What's that? 224. Okay. 124, I was still seeing that. Okay, 124. Okay, this one. So now we have enough information to use Card's rule to find x. And remember, Card's rule is the other two sides and the included angle. But guys, we do still have to write that OD is 8. I'm just going to put 8 units, but I think it's fine if we just say 8. The reason for that was radian. Okay, remember they just said OD. So now we're going to say, therefore, remember for Card's rule is x squared is equal to other two sides squared added together. So a squared plus a squared minus 2 times the other two sides. So a times a times then cos of the included angle. Right, you would type that into the calculator. Right, let's see, what was that value? That was, it doesn't matter, you can just type that in the next square root. Does anyone have the final one? 8.4. 8,42 centimeters. I should say minutes. Final, yes, that's fine, but then you would just have to first calculate one of those. Yeah, perfect. Right, you could have done that back, you could have done sine rule, but then you would have had to calculate either OB in your OB doing angle sine and triangle, angles opposite equal sides. But then you square root it for again. And you guys have my calculator, so I can't. Okay. It's fine. Thanks, let's see, let's see. When you use final, that. Yeah, but cause 124. You know, I'm just that. So okay, that's fine. It happens. All right, 48,13. There we go. It's 1.7. Okay, guys, I would like you please to practice those 3 questions for homework for tomorrow. Sorry that I am giving you homework and no time in class, but I'm trying to finish this chapter. We still have 2 more chapters to do. We'll finish, but we do have to push.